Today we're going to be looking at this really cool problem that I thought of a few years ago, but we haven't actually talked on the channel, and it's not really talked about anywhere on the internet, so I figure I might as well fill in the gap. So I'm asking the question, what kinds of DFAs can we have with the alphabet of the DFA being the empty set? So usually we have the alphabet of the DFA being like A, B, C or something, but here I'm asking, what if there are no characters in the alphabet whatsoever? And what are the possible DFAs with that? Whereas if you have A, B, and C, you can have infinitely many DFAs. What can you do here? So if we have a DFA, we have to have a start state that is completely non-negotiable. But the problem is that I can't have any transition, even an epsilon transition, mainly because, well, DFAs don't have epsilon transitions, and I can't have a transition with a symbol on it because there are no symbols in here. So, in fact, I can't even have a self loop. That's kind of surprising. So, the only possible thing I could do, I could have other states here that are not connected to the start state, but after removing all of them, I can only have one state. All unnecessary states, I can only have one state here. So the only two possible DFAs I can have are either a single state, which is not accepting, or one that is. So these are the two possible DFAs here. And obviously the first one's language is empty set, is the language of the thing. And that one is just the empty string and nothing else, right? Because it accepts the empty string because the start state is an accept state, but it can't accept anything else, obviously. So I want to show you something that's actually really surprising about this. So remember that if we have a DFA that accepts everything, so let's just say we have a DFA that accepts every single string, which in one way you can do it is for all A in the alphabet right here. We can just have a self loop for every character in the alphabet. That accepts every possible string. Well, what about here? Well, we have a self loop for every character in the alphabet right here. Mainly, there are none, but I have a transition for each one. So this tells us something interesting. So the language of this guy right here is sigma star, obviously, because it accepts all strings. But this one has to also be sigma star because it accepts all strings over that particular alphabet. And so we get another way of proving the statement that empty set star is equal to the set which contains the empty string. It's an alternate proof of that statement. You can go through the definition and you can prove it that way, but this is an alternate proof, which I think is pretty cool. So hopefully that was interesting. Leave comments about DFAs with no characters in the alphabet in the comments down below. As always, please like the video and subscribe to the channel. It really helps us out. There are many other links in the video description if you want to support the channel further. And as always, thanks for watching, and I'll see you next time.